Hello, I am Kautuk Raj and welcome to this demonstration video accompanying the work titled From Liberating to Questioning Tabular Data in Documents Using Knowledge Graphs. I will quickly move over the agenda for this video. First, we will be introduced to the topic and the proposed pipeline. Then, we will look at the sample document and the question which will be used as a running example throughout. To observe the performance of existing systems, we will perform some test runs on ChatGPT and ChatPDF, two popular LLM-based question-answer tools. Moving on, we will see a demo of the working of our tool, followed by the creation of QA systems and test runs on QAnswer. In this work, we propose a novel method to extract tabular data from documents like PDFs, Word documents, and web pages, and then perform question answering on this data using a natural language interface. Our approach liberates the valuable tabular data hidden inside documents, first by using open source tools to recognize and extract tables as CSV files. We then transform this into knowledge graphs to enrich and structure the data. The knowledge graph is stored in RDF format. Finally, we employ the QAnswer platform to query both the text documents and the knowledge graphs simultaneously. This allows more complete and accurate question answer over both unstructured as well as structured tabular data from the original documents. A key benefit is the domain-independent nature of handling specialized data, unlike pre-trained language models. We demonstrate these capabilities on United Nations disability documents and web pages to showcase improved performance when interpreting complex table layouts and performing open-ended factual questioning. The document that we want to look at is an initial 2010 report of the Philippines on the rights of people with disabilities submitted to the United Nations Committee under the CRPD. The specific table that we are interested in querying is the one on the number of courses in special education offered. We can observe that this table does not have demarcating lines but rather has white spaces to denote row and column boundaries, as well as carries the property of being spread over two pages with repeating column headers, making it a particularly complex table to handle and query. The question that we want to pose is about the programs offered in the MASPED, Masters in Special Education, in the NCR region of the Philippines. We will perform test runs on ChatGPT and ChatPDF with the previously seen data. OpenAI's ChatGPT interface does not allow uploading documents, so we use a wrapper from Poe. We go ahead with uploading the document and posing our question to ChatGPT. We see that ChatGPT fails to answer a question by saying that it couldn't find specific information. So maybe we try to change by asking specifically about the number of programs, but still it says that it doesn't have any information. We will try to see if it has something or nudge it to see the document. Unfortunately, it says that the document does not contain any data about it, so ChatGPT fails to answer the question, as we realize. Now moving to ChatPDF, a specialized PDF chatbot following a similar drill and asking a similar question. It gives us some explanation about the document and we pose our question. and we get an answer, though we might have to verify the correctness of it. So we move to the document that we have, right? And we see that rather than giving us 7 for MASPED, it gives us 27, which is for MAEDSPED, which also entails or tells us about the fact that the tabular interpretation is not very good. Next, we move to the working of our tool. We first select a document which we want to perform question answer on, specifically on the tables. Next, we click the extract tables button to extract all the tables from the document, and we will be soon be able to see them on the right panel. As we can observe, there were 7 tables and they have been rendered on this page for our viewing. Next, we will create the create knowledge graph button, which will create a knowledge graph and show us the resultant turtle file on the right panel. For the upload part, we can also upload multiple documents in different formats. This is the resultant graph created in the turtle format, which we will use for uploading, but before that we will download the RDF file in turtle format. And now we have the output from the entire process, and we go on to QAnswer to create 2 QA systems for ourselves. We will create 2 question answer systems. One of them will be document based for the unstructured part. Let us go ahead and do that. We uploaded our document and finished the creation of the document based QA system. Next, we will move on to the creation of the graph based or RDF based QA system. This QA system will be created using the RDF file which was downloaded using our tool, and similarly we go ahead and create the RDF based QA system as well. The next step would be to create a combined QA system which would combine both the unstructured and structured part of the document. Choosing the document based and RDF based QA system and combining them to create one holistic QA system which we will use to query our document. Now we will pose our question to the QA system. Let us go ahead and do that, and we can see that by clicking this button we can see results from both the unstructured text part and the structured graph or table part of the document. From the text part, we can see a similar error being committed, though the relevant table is highlighted. The error that we observe is the fact that again MAED/SPED is being used to come up with the answer rather than MASPED, which should be 1 in this case. Whereas we observe that the correct answer from the graph part is highlighted in the graph part of the result along with the sparkle representation. That brings us to the end of this demo video. Thank you for your time and attention.